Hello students, today we are going to discuss about integration. Okay, so basically integration is summing up. Okay, basically integration means we are just summing up things. That means if we have a small property in a small region, we can find out the property along a line or along an area or along a volume. Okay, a small property which is given in a small portion can be extended and that can be found out in a line, in an area or in a volume. Okay, that is integration. So basically we have three types of integration. First one is line integration, where we will be dealing with only one variable. Second one is surface integral, or we can say area integral, in which we will be dealing with two variables. And third is volume integral, and that deals with three variables. So first of all, let us look into line integral, and in that we will be dealing with only one variable. So we will deal with the basics first. So basically how we will represent integration is we will give a sign like this, and we will be writing the function here, and also we will be writing the variable with which we will be integrating it. So here I am integrating with x. So I will write integral f of x dx. F of x is the function which I am going to integrate, and x is the variable with which I am going to integrate. Okay, so we will integrate and find out for different functions. If my function is like this, x raised to n dx, if my function is x raised to n format, I can write it as x raised to n plus 1 by n plus 1. This is the basic format. Actually, integration is just the reverse of differentiation. Okay, so for example, we will just see the integration of x square. So x square dx. So I am integrating with x. So it will be x raised to n plus 1, that is 2 plus 1 by 2 plus 1. And that is equal to x raised to 3 by 3. X raised to 3 by 3. So as I told you, integration is the opposite of differentiation. So if you just differentiate this, you will get this one. Let's find that out. So it is x cubed by 3. I'm going to differentiate it with x. So 1 by 3 will be constant, that can be put aside. X cubed can be differentiated as 3 into x square. So 3 and 3 will get cancelled and I will get x square. Okay, so this is how we will do basic integration. And when it comes to integration, it's a bit different from differentiation. We cannot do everything using the formulas. So we will have to take some more steps to find out the integration. So one such step is known as substitution method. Substitution method. For example, I will just show you. If I have a function in the numerator which is like the differential of the denominator. Okay, so when you just see here, x square minus 1 is in the denominator and x is in the numerator. When I differentiate x square, I will get x. So the differential of the denominator lies in the numerator. So we can do one thing. I'm just going to substitute for the denominator. I'm substituting t instead of denominator. I'm just differentiating this with x. I'm differentiating t with x. So that will be 2x minus 0. So dt is equal to 2x into dx. And dt by t, I am taking this 2 to this side, so it will be 1 by 2 and x dx. So when I look into this portion, instead of x dx, I can substitute dt by 2. I am putting that 2 in front of the integration part as it is a constant. And instead of x square minus 1, I can give t. So this is 1 by t dt. So integral 1 by x dx is log x. Please note this down. So that can be substituted here. So it will be half. 1 by t dt will be log t. So after integration, we need to go back to the real function. Till the integration gets over, we will be continuing with t, and after that we will substitute it back. So it will be half log x square minus 1. This is the final answer.